Perfect.
Three.
Okay. Oh, and Megan, is it okay if you get closer to the computer? It's just kind of harder to hear you.
You
For
can't.
me, at least.
Can you hear me now? It's my
Yeah,
phone,
perfect.
my computer.
Oh.
If I set it up straight, it blocks the microphone.
Yeah, you could even throw headphones on and use the microphone on there, but.
Can you hear me better now?
Yeah. Can you hear me now?
I got 0.175 for number 3.
Okay.
Yeah, 175.
Yeah.
Yep.
Use a normal probability applet to find the combined area under the standard normal curve. Okay. So I just put that z-score on the applet and shade out the middle.
So you want the area to the right of the positive z-score and to the left of the negative.
I guess highlight everything but the middle.
Right.
$1.358.
What? Oh, sorry, I couldn't hear what you said.
Okay, so the area I got was 0.175.
Yes.
Yep, that's what we've got.
Yeah.
Okay. Do you want me to read the next question?
Sure thing.
Which of the following will have a smaller standard deviation of the 9 observation are randomly drawn from a population? Distribution of individual observation X, distribution of the sample means X. This cannot be determined. I think it is the distribution of the sample means X.
The X bar?
X bar, yeah.
X, yeah.
Yeah.
So how does that make sense? It says the 9 observations?
So essentially, the way it works is the more observations that you have, the lower your standard deviation is going to be, because, I mean, looking at it mathematically, the higher the number that goes in the denominator position of that formula, the lower the standard deviation is going to be.
Okay, that makes a lot of sense now.
So the first one means you have 1 observation, but the second one means that you have the 9 observations because it's the sample means.
Yeah, the sample means. That's what I was thinking about, the sample.
Okay.
And that's the law of large numbers.
Yeah, well,
all right.
The whole difference between these 2 chapters is all about the sample. So that's what I thought, that was sample.
But the law of large numbers is related to the standard deviation. And it says that the larger the observations, the larger the sample means, the smaller the standard deviation.
Mm-hmm.
The larger the sample means, the smaller the standard deviation. And that makes sense because standard deviation means spread, right?
How far apart they are from each other.
Mm-hmm.
And if you have more... Okay, I'll make sense of it as we go. Okay.
But really, I mean, mathematically speaking, it's just the larger the number in that denominator position, the smaller the standard deviation is going to be.
Because it's going to be more precise. That's
right.
That's what
we... Okay, yeah, that makes sense.
Because the more numbers you have, the chances of them being closer are higher.
Mm-hmm.
Okay. Mm-hmm. Okay. All right, so we're on 5 now. Which of the following results implies that the spread, or the standard deviation, in X bar decreases as the sample size increases? We just talked about it, guys. I don't know why.
Law of large number. So
yeah,
central limit theorem. Central limit theorem has to do with distribution. And law of large numbers has to do with standard deviation.
Okay, I gotta
That's the way
remember
I remember it.
that. Central limit.
Right now we're talking about spread or standard deviation. So we're talking about the law of large numbers.
Okay. So it's not normal distribution. I'm just kidding. Okay. 6.
Okay. Let's see. U is 150.8. Standard deviation is 8.8.
Diane earned a score of 160 in the GRE. What is the z-score corresponding to Diane's score? So we just take Diane's score and we subtract mu. And then divide it by
2.
Wait, we need one more number.
The standard deviation is 0.8.
Yeah.
So this is just a regular z-score.
Oh, okay. So this one is going to be 160 minus.
I got 1.045, but I think I missed something.
Oh, that's what I've got too.
That's what I got. 3. We rounded 3 decimal places, so 1.045.
Okay, I wasn't that bad then.
What is a probability that a randomly selected student will score above 160?
Oh, okay, we need doublet.
So
let's plop this z-score in.
That would be 1.148.
That would be point.
Yeah.
148.
Sorry, I always get
it would be a
0.148. Yeah.
So like 15% chance that somebody could test higher.
Not pretty much.
Yeah.
Okay. So
I hope I have a 15% chance.
yeah.
I hope I am in the 15%.
Oh, and did you see how we did that, Megan?
Yeah, you just put the z-score in and then you highlight the right side.
That's right.
Perfect.
Okay. Christina, do you want to read the next guy?
Sure. Question 8. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? So we'll need to find the sample mean to begin with, and then use the formula to get the z-score of the sample mean.
Okay, so the sample mean is 800 divided by 5?
5.
So
Yeah.
sample mean is 160.
Mm-hmm. There you go. 2.338.
I was like, I remember I had a bad day. Allie, Megan has some.
Oh my gosh, Katie, get out. I'm doing a video.
And she was like, and she goes, you've had a bad day. Right? Right how you did it.
Okay, I'm doing a school thing.
Okay, so
Oh,
then
that's really awkward.
Kate, get out.
I'm sorry.
That's okay.
Close the door.
Okay, so the z-score for this formula, or the formula for this z-score, is x minus the mean over the standard deviation divided by the square root of the sample size. 5.
Yeah, 5.
okay, so I have how do we get the, hold on.
Coda, get away.
Oh, we use the standard deviation from up top, right?
Yes.
8.8.
Do you remember how to get the mean, like from different samples? The mean will be the same because this for sampling is always the same. So you got the mean, and then
So essentially, the mean of those 5 numbers is 160.
yeah,
And then the mean from up above is 150.8. So 160 minus 150.8.
So that 9.2 divided by,
root square of 5.
The standard deviation is, 8.8. And then over the square root of 5. So for the 8.8 over the square root of 5, I just rounded to 3 decimal places. So I got 3.935.
I got 3.338.
Well, but then, so then 9.2 divided by 3.935.
Okay.
did you
So
guys
that
get
was just
0.3?
that was just the denominator. So I got 2.338.
Okay.
Yeah, sorry. That, let's see.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So we just use the probability applet again.
Yeah, it's
What is
just
2.338.
nothing.
No, because that's not a
No.
probability. What's the probability? Oh, you mean with that z-score? Yeah.
Yeah, it's 0.00. It's pretty much no chance.
Yeah, almost 0 is 0.0097.
It says 4 decimal places, so 0.01, or sorry, no, 0.1.
0.01.
0. I have 0.097.
Mm-hmm.
Oh yeah, it's just 0.097.
Yes.
0.0097.
Yeah.
Okay, yeah, that's what I meant.
Round up 9, that becomes a 10. So it's 0.01.
Well, we don't round the 9. We would round the 7, but we don't know what's.
No, if we want 3 decimal places, we have to round the 3rd decimal place.
Oh, they want 4.
Does it say 4?
Yeah, for
Oh,
decimal place.
hallelujah. Okay, good.
All right.
Buddy, you're waking up. Okay, suppose the GPA of BYU Idaho students is 3.5. The standard deviation is that. Okay, the distribution is left skewed, and the randomly selected sample is 81, so it doesn't matter what skew it is.
Mm-hmm.
Yeah. It's also approximately normal. They want to draw us crazy because it's always the same. They say, I think it's normal.
Yeah, approximately normal, because 81 is a big sample.
What is the mean of the distribution of the sample? Mean sample distribution for all possible sample size 81 that could be drawn from the parent population. And this is 1 decimal place. The answer, 1 decimal place.
What is the mean of the distribution of the sample means?
Yeah.
What's the mouthful?
3.5, right?
Yeah, that's what I got.
It's the same mean as the parent population.
Mm-hmm. Yep. They like to confuse us.
Yes. They like to try to confuse us.
Yeah.
Okay, so now
Standard deviation.
we do 3.3 minus 3.5. And then you
Yeah,
divide
there you go. And
you
Wait,
divide it
what's
by 0.7 divided by the square root of 81.
Hold on. Where did you get the? Okay. All possible.
it's because the sample size is 81, so the square root.
No, where'd you get the 3.3?
Oh, it's just they want us to get the probability of it being less than 3.3 on the question.
Yeah, we can put
And then I'm just finding the
Wait,
Z
what
score.
question are we on?
12.
12.
We're on.
Right.
Yeah.
What is the
What
standard
is-
deviation?
Whoops, I scrolled down too much. Anyways.
For 3.3 will be
Okay, so then what's the standard deviation? It's the same, right?
yeah, the standard deviation is always the same. Well, they say that there are more, but we are just learning this one.
Well, the standard deviation of the sample.
The sample is 81 too. Well, and then a square 8 yeah, a square root of 81 divided by square root of 81.
What?
Wait.
No, the standard deviation divided by the square root of the sample size. So 0.7 divided by the square root of 81, which is 9. How many decimal? Okay.
Okay, so I did 0.7 divided by the square root of 81.
Mm-hmm.
Did I get
It's
0.077?
0.077.
Yeah, 7.8.
8.
0.078.
Yeah, that's
So what is this? What does this tell me? This new thing?
This is just finding the standard deviation of the sample means. And then we'll use, we can use this later.
Wait, so the law of large numbers doesn't apply to this?
Dude.
well applies in certain way because, for example, as we say, because it's the sample is large, the smaller standard deviation you will have.
Oh, I see.
Which
Does-
is true in this case because the standard deviation was 0.7. Now it's 0.78.
Oh, I see. Okay. Wow, that makes a lot more sense. Okay.
Okay, the GPA 81.
So for 13, yeah, I found the 3.3 Juan was talking about earlier.
Yeah, sorry, I was skipped.
No, that's okay.
Okay, so then you get 3.3 minus 3.5, and you divide that by
The square root of 81. 0.005. That's very small. Even smaller.
So,
So you guys get negative 2.56 for the z-score.
Oh, for the
Oh,
z-score.
I'm still.
Let me block this thing.
What was that? I got negative 2.57, and I'm sorry, 7. What? 2.564.
Yes, that's what I got.
Okay.
Then you just highlight the right side. Wait, no, less than 3.3. You highlight the left side.
Mm-hmm.
Be very small.
I got 0.005. So 0.005.
Yeah.
Is that a bird?
It's a squeaky toy.
Oh, okay.
I didn't know you guys could hear that. It's my dog.
I thought it was a bird.
Okay. Are we good with question 13? Should we go on to 14?
Yes.
Yes.
Okay. So now what's the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? So
This
we could either
minus
subtract.
100 minus. So
Yeah.
0.9 995.
999,995.
5.
Yeah, 0.995.
Yeah, you're smart using math. I was just highlighting the pretty graph.
Good either way. It was faster for me to highlight.
Okay, so okay, we gotta let Megan participate because then when he looks at the video, it's gonna be like, hey, where's Megan?
Okay.
Yeah.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, that then was observed in this sample.
Perfect.
Okay.
Sample 48 commercial, so it will be a square root of 48. Then the standard deviation of passengers is so 185 minus 177.6. That's 20. I think the percentage will be 0.055. No, let me just double check this.
Standard deviation is 26.7.
Mm-hmm.
And I get that by the sample size, which is 48. The square root of 48.
Yeah, the square root of 48. That's what I got.
Okay, so then I get a z-score of 1.9.92. And then I want something up to there and more extreme.
Yeah, I still got 0.055. Yeah, I double check.
I got 0.027.
Let me see.
Did I do that wrong?
I don't know. Let me double check again.
Hey, buddy, you gotta go to sleep.
Um,
177. 80. So you did 185 minus 177.6
Yes.
first? Yeah.
actually, yeah, the other way around.
I mean, yeah.
Yeah.
Well, is the so
Yeah. So I just got. Wait, 97?
Okay, so, oh, so the probability. Okay, so I want to make sure I'm doing this correctly. Okay, so I'm finding the z-score by taking the sample mean and subtracting it from the mean weight of the passengers of 185 all over the standard deviation of 26.7 over the square root of 48, which is the random sample. That gives me a z-score of negative 1.920. And then I put that into the applet and I'm highlighting the left and the right. Is that correct?
I think, yeah. Let me see one more time.
I think what's throwing me off is the question. Will
Yeah.
have a weight that is as extreme or more extreme than was observed in this sample.
Yeah, and then it says either above or below the mean. So
So the left and the right side.
Yeah, so I just think that's their way of saying
0.055 then.
yeah.
But how many decimals? 3 decimals. 55? 0.055.
Here goes nothing.
Oh, is that it? Okay. You submit.
All right. Yay, 100%.
All right.
Okay.
Good
So,
job.
you submit our group chat, and then for us to mark the assignment as complete, you can just go on and put a decimal point on the discussion thing, and then it'll check it off your iLearn.
What was
Wait,
that?
tell me what? Because mine have just been going unchecked these past
Okay,
weeks.
yeah. In order to get that to be checked off, just go onto the discussion and then reply to thread and then just put a decimal point.
Reply to thread. Okay. Perfect. Good. Thank you.
And then there you go. So that way your iLearn looks spiffy.
So
Yeah.
you have to reply in order to get the.
No,
you'll-
you're going to get the credit anyway. But if you want iLearn to get checked off so that it doesn't look like you've still got stuff to do, like mine has for the past few weeks, then you can.
Oh, okay. Yeah, I never did that ever. I never check those ones. I just do the homework.
Oh my gosh, I check them all the time. that's
Yeah.
my Bible.
It's just to have a personal, it doesn't actually affecting the grade. It's just
Nope,
for you.
it's for OCD.
It's your checklist.
Yeah.
Yeah, it's just your personal decisions make. All right. Thank you,
Okay,
guys.
sounds good. Thank you.
All right, see you next week.
See you
Okay.
next. Bye.
Bye.
Have a good week.